Hello Year 10, it's Mr. Heinrich again. Welcome to our 6th lesson on the electricity topic. We're going to look at the topic of filament lamps and diodes, so two of our circuit components in this lesson. So your starter task, which you should have had seen already on Padlet, is a short educate quiz, which your teacher will have sent you the link for. Okay, so please have a go and complete that first of all. If you've not done that, pause this video and go and complete that quiz. So let's think about light bulbs, lamps. Okay, so I wonder if you've ever switched on the light bulb and hear it suddenly pop and fail. Okay, and that obviously those things can happen at very inconvenient times, typically when we turn on the light because we need it. Most of those electrical failures happen because we put too much current through a component in the appliance. Now it might be because there is that appliance has worn out, and the current causes that appliance to fail. So we're going to look today at the lamp, the light bulb, and the effect that the light bulb has in a circuit. So the modern filament lamp that we know about with its carbon filament was actually invented by someone called Lewis Howard Latimer, who was an inventor around the same time as Thomas Edison, who I'm sure you've heard of. Edison actually invented a light bulb with a slightly less suitable filament, okay, and then subsequently patented a more useful version. But what we know about a lamp is that when we apply a current to it, the filament that's inside it, which you can see here, okay, heats up and it starts to glow. And the glow from that filament is then illuminated by the glass bulb to emit the light. Now obviously this is different to the modern energy saving light bulbs that we are seeing and using a lot more of now, but traditional light bulbs have these filaments in. Okay, now in order to measure the resistance of a filament lamp, we need to set up a circuit. So here's an example of a circuit. I'd like you to pause the video and draw or sketch this into your book now, please. Okay, and so I'm going to demonstrate using our simulation software what we see when we investigate this a lamp in a circuit. So here's my FET animation, which you may well have seen already. Okay, we have, let me just run through what we've got in our circuit. We have a single battery, we have a cell up here, we have our ammeter, we have our filament bulb with our voltmeter across the bulb, we have a resistor here. This will normally be a variable resistor, but obviously I can change the resistance of this resistor just by clicking on it and altering the resistance. And I have a switch to turn on the circuit. So let me start the lamp, start the current, and we can see that as our current flows, as we would expect, our lamp is shining. We have a current of about 0.45 amps and a voltage of about 4.5 volts. Now what I can do is I can add another cell into my circuit. Okay, so if I pop another cell in there, and what we notice obviously is we've got now more current flowing, we have higher voltage across the bulb, and because of that we have a brighter bulb. The bulb is emitting more light. Now equally I can alter the resistance. So if I reduce the resistance, we can see what happens is that the voltage increases and the current increases and the bulb begins to get brighter. If I increase the resistance, we can see that my bulb gets dimmer and dimmer and the voltage and current come down accordingly. Now, so that's the first point from our video, okay, is that an increase in potential difference will increase the current and therefore will increase the brightness of the bulb. Okay, now what we're going to look at right here is what happens if I alter these bulbs around a bit. I'm going to switch the bulbs around, and I want you to notice now on this simulation it doesn't unfortunately tell us exactly the same thing. We should be what we would normally get is a negative value here. I want you to imagine that this current is also negative. I don't know if I can actually, maybe it does work. It doesn't matter which direction I put the ammeter, it doesn't give me a negative reading. However, what we do see is we get a negative reading on our voltmeter. So if we get a current flowing in the opposite direction, okay, current is now still flowing, but it's flowing in the opposite direction, we get a negative reading on our voltmeter, and that's important for our next kind of activity. But again, I can reduce the resistance and have the same effect. And if I reduce the resistance too much, and let's just add in another battery here, another cell, we can see that the electrons are flowing very, very fast, the bulb is very bright, and eventually there'll be so much current that the filament will burn out. Okay, let's cancel the switch. So here is some typical data from an experiment looking at that resistance of a filament bulb in a circuit. So we've got potential difference, and as you can see, potential difference is in voltage is going down to 0 and then continuing, because here is where we have switched over the wires and sent the current around the different direction, okay, around the opposite way. So you can see we get negative values. Now, to work out resistance for these values, and this is going to be your first task after you've watched this video, we will need to use our equation of V equals IR. So if you remember what you should be doing for that, so you will need to use our V equals I times R equation to find out resistance. So we will need to rearrange that in order to work out R. So resistance will give us voltage divided by current. So what you're going to be asked to do is to work out these values for resistance down here. Okay, as an example, the first of these, 2.79, I'm sure that's not drawing, divided by 0.2, gives us an answer of 13.95. Okay, so that's how we would work out that data using the circuit that I've just shown you. So the question is why? The question is, why does the brightness of the lamp increase? Now, as I've already mentioned, it's to do with an increase in heat. So what we know is that in that filament, which is normally made of some sort of metal, which is protected by carbon, okay, there are our metal ions and our delocalized electrons. We've already learnt about resistance in a previous lesson. And as that resistance increases, so as potential difference current increases across the lamp and the current through the lamp increases, then these delocalized electrons start to move about and the metal ions start to vibrate more and they are interfered and resistance increases. And when resistance increases, temperature increases as well. Okay, so there is some true or false questions. So I'd like you to pause the video now and have a go at these true or false questions. So all of these questions, the answer is either true or false. Okay. Now we're going to move on and look at another of the components that are found in circuits called the diode. Now the diode and the graph that we find from a diode is very different to a filament bulb. You will draw a sketch graph of the relationship between potential difference and current for a bulb shortly. But our graph for a diode, as you can see, is very different. The current through a diode actually only flows in one direction. We call this the forward direction. Okay, and the current is not directly proportional to the potential difference. So what we can see here is that it doesn't go up at directly proportional. Resistance changes as current changes. And actually in the reverse direction, there's virtually no current flowing. Okay, it's almost zero. So resistance is actually a lot higher. With a much lower current, the resistance is a lot higher than in a forward direction. So a diode is what we call an example of a non-ohmic conductor. If you recall from our work on resistance and resistors, we looked at something called the Ohm's law. And Ohm's law talked about a potential difference and current being directly proportional. So this is an example of a component that is not directly proportional. And a diode is a safety device. It's used to only allow current to flow in one direction. Okay, so your independent work that I'd like you to have a go at. First of all, go back to the table in the video, copy and complete the table of data. Okay, so go through that data and have a look at calculating the resistance, and then use that data to plot a graph of potential difference against current. Now it's important to remember that both the axes will go from negative to positive, so you need to think about positive and negative components in maths. Okay, so you're drawing a cross graph. So you can complete it on paper, or if you feel confident, you can do it on the computer. Once you've done that, there are 2 videos on kscience.com for you to watch, and these will consolidate your ideas. One is about filament lamps, one is about diodes. Okay, in those there are some notes to take down, and then there are some gap fill questions at the end of the videos for you to have a go at. Your teacher may ask you to upload all of that, some of that work to their assignment on Teams. That will be explained to you in Go for Schools. Okay, good luck, and I'll speak to you next time.